Tech It For Me is an independent and solo-produced podcast.
Welcome to the Tech It For Me podcast. I'm Mike Madole. So here's the question. It's 2025. We have mesh networks, gigabit internet, Wi-Fi 6, and even Wi-Fi 7 is breaking through the horizon right now. So why does Wi-Fi still suck? You know what I'm talking about. You're paying for high-speed internet, but your video call drops the moment you move rooms. Your smart TV buffers right before the good part. Your phone shows full bars, but web pages load like it's 2003. Today, I'm going to break down what's really going on with Wi-Fi, why it's still so frustrating, and what you can actually do about it. No magic fixes, just real talk based on years of running home labs, setting up networks, and helping people figure out why their fast internet still feels slow. This is Tech It From Me. Let's go.
This is the Tech It From Me podcast.
Let's start with the most common misunderstanding I ran into, because this is where most of the frustration begins. Wi-Fi is not the internet. Wi-Fi is just how your devices connect to your network. The internet is what your modem connects to outside your house. It's the difference between the hallway in your house and the street outside your house. If you can't get down the hallway because it's blocked with furniture and cats and kids' toys, that's not the street's fault. So when your Wi-Fi is slow, it might not be your internet service provider, or ISP, as it's known throughout the industry. In fact, in a lot of cases, the speed coming into your home is fine. It's what's happening inside your home that's the problem. So let me tell you how I've set mine up, because I've gone through some trial and error over the years. I'm on a cable connection. I have 1 gigabit coming down, 30 megabits going up. It's pretty standard here in Canada. Now, when I first set it up, the ISP gave me one of those combo modem router units. You know the ones, one box, Wi-Fi and modem all in one. And like most people, I used it as is for about a day or so. Then I turned the Wi-Fi off completely. Why? Because those built-in routers are almost always underpowered and poorly placed. Mine was placed in my basement home office, surrounded by ductwork and drywall. It's not ideal. Instead, I switched to a TP-Link Deco X60 mesh system. Full disclosure, I am not sponsored by, nor have I ever worked for TP-Link or an affiliate of theirs. It's just what I chose to use. It was during COVID, and that's, after my research, what I ended up landing on. I have 3 access points in total. Each of my access points have 2 Ethernet ports and a power port. The primary unit is wired directly into the modem and a network switch, and the other 2 are strategically placed in my house on each floor. But more importantly, they're also wired, backhauled with Ethernet cable. The Deco X60 is capable of a wireless backhaul, but hardwiring makes a huge difference. A lot of people get mesh systems thinking they'll fix everything wirelessly, but if the access points can't talk to each other cleanly, you're still in trouble. Another feature I requested from my ISP was IP Passthrough. Now, for the less than tech-savvy listeners out there, this is not something I would recommend unless you have some technical know-how. IP Passthrough means the modem hands off the public IP address directly to my router, and then the router takes over from there. It simplifies the network. There's no double NAT, no weird port forwarding issues, no modem trying to be a router when it really shouldn't be. If all that flew over your head, don't worry, we're keeping this podcast high level. If your ISP supports pass-through or bridge mode, use it. It's a cleaner setup, and you'll thank yourself later. All right, so let's say you've got a decent internet plan. Maybe you've even gone out and bought a mesh system. You followed the quick start guide, put the access points around your home, and you're still getting spotty coverage or inconsistent speeds. So what gives? The truth is, wireless networking is messy. You can't see it. You can't touch it, and there are a million little things working against you. It's a silent war happening in the air around you, one that's constantly changing. Now, let's talk about what's really causing the headaches, even when you've done everything quote unquote right. First off, there's signal interference. This is still a major issue in 2025, especially on the 2.4 gigahertz band. That frequency range is like an old, overcrowded highway. Everyone's using it, smart devices, Bluetooth, baby monitors, even your microwave. And it's not just your gear causing interference, it's your neighbor's stuff too. You could be getting blasted by 5 different networks coming from the unit above you, plus wireless cameras and motion sensors next door. Even your fridge can reflect and distort a Wi-Fi signal. I've personally had smart devices, like some of the ones I use for my Christmas light show, drop offline just because they were too close to a metal shelf or another wireless gadget. It's all invisible, but it matters. If you're constantly battling with spotty connections in the kitchen, near the laundry room, or beside a massive TV, there's a good chance interference is to blame. The second contributor to bad Wi-Fi is bad placement, and this one is way more common than it should be. I've seen routers stuffed into basement corners, behind entertainment centers, in cabinets full of wires, or the worst, shoved inside metal utility boxes zip-tied to furnace pipes. Look, Wi-Fi signals don't like tight spaces. They don't bend around corners, and they really don't like metal, concrete, or water. The placement of your access point can make or break your coverage. Things you want to consider when placing the access point devices: height. Signals travel better when elevated. Open space. Don't bury it behind a bookshelf. And a centralized location. Think about where most of your devices are, not where the cable outlet happens to be. At my place, I've got 3 access point units. I was intentional about placement, not just plugging them in wherever there was an outlet. The broadcast range you often see on the box is under normal circumstances, and that's with air quotes. It doesn't take into consideration multiple walls or floors that you need to go through. The third component is device overload. This is a big one people don't think about. Back in the day, your network maybe had a couple of laptops, a printer, and maybe your phone. Today, it's a circus. A rough head count from my house right now: phones and tablets, check. Smart TVs and streaming boxes, yup. Security cameras, yeah, I've got a bunch. Smart plugs, lights, voice assistants, robot vacuums, 3D printer, a NAS. I have Christmas light controller hardware, laptops, desktops, guest devices. We're talking 70 plus connected devices easily. And remember, every single one of those is whispering to your router all day long. They are doing things like checking in, they're synchronizing, they're pinging the cloud, they're updating firmware. These tasks individually aren't bandwidth hogs, but collectively, they create noise. They increase chatter on your network. And some of them still use 2.4 gigahertz exclusively, which clogs up that already overloaded band. Your router has to manage all of that traffic all the time. And that's a lot of juggling, especially if you're still relying on a basic consumer-grade access point. Number 4, wrong expectations. So here's the quiet killer. We expect too much from good enough gear. People buy a mesh system expecting it to be magic. And don't get me wrong, mesh is great. I use it. It works well if you set it up properly. But what people don't realize is that mesh nodes still need a solid connection between them. If your secondary unit is just barely holding on to a weak signal from the primary one, congratulations, you've just extended your weak signal farther across your house. You're spreading the pain. This is why I recommend Ethernet Backhaul. It's such a game changer. My 2 satellite units are both wired. They're not guessing or repeating. They're working like true access points on a unified network. Without that, you're just asking your mesh to work harder, introduce more hops, more latency, and more opportunity for drops. So yeah, mesh is good, but only if your environment supports it. Otherwise, you're setting yourself up for disappointment. So, okay, enough doom and gloom. Let's fix the problems. If you've been nodding along to everything I've said so far, thinking, yeah, that's my house, here's the good news. You can absolutely improve your Wi-Fi. You don't need to hire a network engineer or drop thousands of dollars on enterprise gear. You just need to make a few smart choices. So here's what I recommend, based on my own setup at home and what's worked for my friends, family, and frustrated coworkers over the years. Step 1, turn off your ISP's Wi-Fi. Seriously, just shut it off. Most ISP-provided modem router combos are terrible at wireless. They're built to be just good enough, and they often cause more harm than good when you introduce your own hardware. If you're using a mesh system or even a single third-party router, you don't want two devices broadcasting separate Wi-Fi networks in the same house. This causes interference, confusion for your devices, and a whole bunch of frustration you just don't need. In my case, I've completely disabled the Wi-Fi on the ISP modem. It just acts as a dumb modem now. All the work now is being done by my Deco X60 system. Number 2, nail your placement. This one's easy to ignore, but it so much matters. Wi-Fi isn't magic, it's radio waves. And radio waves get absorbed, blocked, and bounced around by your home. Your access point shouldn't be tucked behind your TV, or buried in a cabinet, or sitting on the floor next to a pile of wires. Instead, place it high on a shelf or mount it on a wall if you can. Keep it away from metal, large appliances, and thick walls. Make sure it's centrally located, not just where your ISP ran the cable. Before I installed my mesh nodes, I took the time to walk around the house and test different spots using a Wi-Fi analyzer. That extra few minutes of effort meant better signal in every room and fewer complaints from my family. So, what is a Wi-Fi analyzer tool, and how much does that cost? Don't worry, you don't need anything fancy, and how does free sound? So here are a few free or low-cost options anyone can use. So first, for the Android users, download an app called Wi-Fi Analyzer by Farproc or Wi-Fi Man by Ubiquiti. Both are solid, user-friendly, and show real-time channel graphs and signal strength. For the iOS users on iPhone or iPad, Apple restricts full Wi-Fi scanning, but you can still use the airport utility. It's a free app from Apple. Go into the app settings, enable Wi-Fi scanning, and you'll get signal strength and some basic data. Last but not least, if you're on a Windows or Mac OS machine, try NetSpot. It's free for basic use and gives you heat maps, channel congestion, and more. Another option on Windows is Acrylic Wi-Fi Home, which has a slick interface and solid diagnostics. Even just spending 5 minutes with one of these tools can help you make smarter decisions about placement, channel selection, or whether you need a better access point. And hey, you might be surprised at what you find with the results. Third is hardwire where you can. I know, cables are annoying, but this is one of the best things you can do. If you can plug something in, do it. So that includes your mesh nodes, so that Ethernet backhaul we talked about earlier, your desktops, your gaming consoles, smart TVs, streaming boxes, even your home office gear. Wired devices don't just get faster, more stable connections, they also free up wireless bandwidth for everything else. I ran a couple of Ethernet lines through my house when I moved in, and it's made a massive difference. My 2 satellite access points are hardwired, and that alone took my mesh performance from meh to rock solid. And speaking of running wires, I've seen on multiple occasions people have run their own cable through heat vents or cold air ducts. Please don't do this. Air ducts, especially return air ducts, are part of a building's HVAC system, your home's HVAC. Running any kind of cable inside them exposes it to air circulation throughout the home. Most Ethernet cables with standard PVC jackets are not plenum rated, which means they could emit toxic fumes if they ever caught fire. If that cable were to overheat or be exposed to a short, it becomes a risk that now is circulating throughout your home's air system. Code requires plenum rated cable, typically labeled as CMP, in any air handling spaces. And lastly, once a cable is inside ductwork, it's hard to access if something goes wrong, whether that's a bad crimp, a damaged line, or an upgrade later on. You might have to cut into ducting to fix it. So what you need to do instead is run through joists or along baseboards. If you have an unfinished basement or drop ceilings, run the cable through framing or staple it along the floor joists. Use surface raceways. In finished spaces, surface mounting raceway like D-line or wire mold is a clean, code-friendly way to hide Ethernet along baseboard or trim. If you can, run through wall cavities. You can fish cable vertically through wall spaces and use low voltage mounting brackets and wall plates to keep things neat and tidy. Another option, attic or crawl space routing. If ductwork is tempting because you're avoiding finished drywall, consider attics, crawl spaces, or even behind closet walls instead. The fourth way to improve your Wi-Fi is use your own router. If you're still relying on your cable company's all-in-one modem router to handle your entire network, just upgrade. Even a mid-range mesh kit or standalone router from TP-Link or Asus or Netgear will perform better than most ISP gear. You don't need to spend a lot of money, but you do need equipment that's designed with modern networks in mind that are going to support multiple devices, smart homes, work-from-home traffic, and online streaming. Another option, be smart about 2.4 gigahertz. Most smart home gadgets, such as plugs, switches, doorbells, etc., they still rely on the old 2.4 gigahertz band. It's fine for low-speed stuff, but it's also a super congested band. If you've got 30 or more smart plugs all pinging the network every few seconds, that band gets noisy very quickly. Some routers will let you create a separate SSID just for 2.4 gigahertz devices, or better known as creating VLANs. So for the more casual listener, an SSID is just the name of your Wi-Fi network. A VLAN is like separating virtual lanes on your network, so your smart devices don't slow down everything else, kind of like how an HOV lane would work. You can also, on some routers, schedule updates or network access windows. And always monitor individual device traffic. At home, I've segmented my network so that noisy IoT devices don't clog the main Wi-Fi that our phones and laptops rely on. You don't have to get crazy with VLANs, but even separating devices logically, that can make a huge difference. And a pro tip, if you're in a condo or an apartment, you're probably not going to win the interference battle entirely. There's just too much wireless activity packed into small spaces. So instead, focus on managing that chaos. Use wired connections wherever possible. Stick to 5 gigahertz or 6 gigahertz for your main devices if your router supports it. Consider creating a guest network for that noisy IoT gear. And pick strategic times for firmware updates and backups. Sometimes it's not about perfection, it's about consistency. The bottom line is this: you don't need enterprise-grade gear to get great Wi-Fi. You just need to think like a network, not just a consumer. Be intentional. Plan your placement, wire where you can, and most importantly, don't expect miracles from bad equipment or rushed installs. Trust me, your future self and everyone in your household will thank you. I just made mention of the 6 gigahertz band, so a quick word on Wi-Fi 6, 6E, and Wi-Fi 7. They are better. I agree. There's more channels, there's more bandwidth, and better handling of multiple devices. But even that newer technology does not fix physics. A signal still will struggle through brick. A faster protocol is not going to help if your access point is behind a water tank. And most people aren't even using devices today that support the newest standards yet. So, yes, upgrade when it makes sense, but don't expect a new router to magically solve a bad setup. So Wi-Fi doesn't suck because the technology is bad. It sucks because most people don't realize it's an ecosystem. Placement, hardware, interference, and usage all play a role. The good news? You don't need a network engineering degree to make it any better. A few smart tweaks can go a long way. If you're struggling with Wi-Fi at home, I hope this podcast helped point you in the right direction to fix it. And if you've got your own war stories or even better, solutions, please feel free to drop me a note. I'd love to hear them. Thank you for tuning in. This has been the Tech It For Me podcast, and we'll see you next time.
Tech It For Me is an independent and solo-produced podcast.